Hey guys, welcome back to our final little section on transformations here, which is dilations. And for the think slash form, I have what does it mean when your pupils dilate? The pupils in your eyes, right? They get bigger and smaller. That's essentially what dilating is you're either making something larger, but keeping it the same shape, right? Your eye doesn't, your pupil doesn't change from a circle, right? It just gets bigger and smaller. And that's exactly what a dilation is. So a dilation is a transformation that produces an image that is the same shape as the original, but is a different size. So in graphing, you could think of it as stretching or compressing, right? So we're just moving values, multiplying values. So like other transformations, let's see what happens when we apply this to the outside and inside of a function. Let's say f of x equals the square root of x. Now, here, when I'm talking dilations, I'm talking multiplying, right? So let's do this. So when we multiply this outside value by 2, let's get some intuition here, right? We're saying whatever y value or f of x value, right, whatever output we're going to get that you would have got, just multiply it by 2. So when we're thinking outputs, I bet you that this 1, 1 here is going to go up to 2. I bet it's just going to get multiplied by 2. And sure enough, it does, right? And the same thing happened down here, right? This where the output was 2, I'm saying, hey, just multiply that output by 2. And now it's at 4, right? So that's all that does, right? You're just multiplying the y value. Now, what's interesting here is now, let's think about what might happen if we do it to the inside. And I think it might be harder to think of that right away. So you're saying, take whatever you were originally going to put in for the x and double that. That's going to kind of stretch the x's in a way, and I think it's best if we just see what happens. Let's put a 2 in here and see what happens, right? Let's see what happens to this point 4, 2. So 4 was at 2, and now it's up in a weird spot. Like, we don't really know where it went. But hey, let's look at this. Look what's at a really nice spot right now. It almost is like it moved left and right instead of up and down, which is kind of what happened on the inside of functions before, right? Let's pay attention to this point. So before, I was saying, paying attention to that point, you probably looked up here and you're like, well, that's not nice, but look what happens, right? Look left and right now. It's cut it in half, isn't it? So that's kind of weird because we multiplied it by 2, right? And this kind of goes with that concept of when you do something to the inside of a function, right? When we were doing translations, it was opposite day, right? If we added, we really moved left. And there was that intuition about 0. And let's think about this, right? The same thing kind of happens. The reason that we've halved this in the x's, right? So it was here at 4, and now the same value, oops, that is not what I want to do. Now, what happened when we put that 2 in there is the x is halved. And the reason that is because now you're saying, well, now when you plug in x is 2, what you really have is 2 times 2, which was 4, right? So that's why you've kind of scrunched these back, right? And so if I were to multiply actually by 1/2, it does the opposite, right? 4, where it was at 2, has now gone out to 8. It's doubled, right? And so just a couple things to take note of there. And that is what is going to stick with the rest of this lesson. So when we're talking outside, get my pen here. When we're talking outside of a function, we're multiplying straight up just outside the function, and then inside or with the x is what I like to say. And I think we are probably getting used to these things by now. And so for our square root function, that would be outside. We just did it. And before I do that, real quick, let's write down what happened when we multiplied by a. So what we did here is when it was on the outside, we multiply the y values by a. And then what happened here was we multiplied the x values, right? Now that we're inside with the x, we multiplied the x values not by a, but really by the reciprocal. The reciprocal of a, right? Because when we multiplied by 2, what we really did is we shrunk it in half. And when we multiplied by half, what we really did was doubled it. So we really multiply by the reciprocal. So now that that's done, let's do our, on the outside for our square root, that would be there. On the inside, for our x squared, on the inside, right, on our absolute value, on the inside. What else am I missing? X cubed is going to act the same as x squared. The cube root of x is going to act the same as that, and so I could probably just get away with giving you guys, right? That would be multiplying to the outside, right? We have 2 to the x times something else, or multiplying to the inside would be inside that exponent. And I think you guys could infer the rest from these 4 that we might run into. With that said, let's get into some examples here. So on Delta Math, if we have 4 times the square root of x, which is on the outside, what we're really going to do is we're going to multiply this x value, or this y value, by 4. So right now the y value is at 1, and so really we're going to multiply the y value and put it up at 4. And that's going to work. Let's get one that's not the square root of x. Okay. Now we have 3 times 2 to the x. We have this 3 again. It's on the outside. So when it's on the outside, we're multiplying by the y value. So this y value of 2 is really going to get multiplied by 3, or be 6, right? And it kind of makes sense that when we multiply a higher number on the outside, we're just going to go up faster, right? Take whatever you got, whatever your y value, your answer was, and multiply it by 3. Now, let's move on, or let's do this fraction one, 1/4. So a good one to think about here is I don't really want to touch 1 because that's not going to be nice, but take whatever, it's on the outside, so whatever y value you have, and reduce it by a 4th, times it by a 4th, right? 4 times a 4th is going to be 1. So that's where we have to be a little comfortable with our fractions. There we go. Now let's do some of these level 2 ones. Okay, now it's on the inside, right? So we have the cube root of 8x. Now remember, now that we're with the x, we're going to multiply it by the x's, but not by 8, by the reciprocal of 8. And the reciprocal of 8 is going to be 1/8. So really, if we multiply the x values by 1/8, this one is going to be a good one, right? We're out at 8, and let's multiply the x value by 1/8. When we do that, we're going to get them all the way back, right? 8 times 1/8 is 1. So let's take this point, and we've multiplied the x value this time, right? Not the y, the x. So we're going to move the x down to 1. But we're keeping that same y value that it was out here at 8. Let's do maybe another one. So again, the square root of 4x, now we're inside with the x, right? And what this really means is we're going to move on the x's left and right, but we're not going to multiply it by 4, we're going to multiply it by 1/4. And if we multiply 4 by 1/4, that's going to be 1. See if we can get one with a fraction. There we go. So now it's inside with the x's, right? So we're going to be moving left and right on the x's. Now that we're multiplying by 1/4, we're actually going to be doing the reciprocal, which is multiplying by 4. So we're going to stretch this out that way, right? Multiplying 1 by 4 gives us 4 because the reciprocal of 1/4 is 4/1 or just 4. All right, and then let's just get a few of these. This is with everything mixed together. Let's get maybe a crazier one. Here's a good one. So we have a lot of stuff going on here, right? When we have all this stuff going on, this is combining everything we know. It's about just taking everything into account. Remember, negative on the outside meant reflect over the y-axis, right? It said take whatever value you get and make it negative. Now, we need to, this dilation is on the inside with the x, so we're going to move in the x direction, but instead of multiplying by 1/2, we're going to multiply by the reciprocal, which is 2, so this 1 should really be a 2. And then finally, this plus 5 is a translation, and it's outside, so we're just going to move that guy up 5. So these ones, you just have to take it step by step. We'll do a few of these. So this one, negative on the outside again, means reflect over the x-axis, right? Take whatever value you had for y, make it negative. 1/3 on the inside really means multiply. We're gonna increase the x's, multiply those by the reciprocal, which is 3. So let's move that 1 out to 3 because 1 times 3 is 3. And then again, we're gonna move up because that's on the outside, up 4. All right, let's get one I like in here. All right, let's do this one. So first thing, this is on the outside, right? This dilation, this multiple of something is on the outside, which means we're going to increase the y value. We're going to multiply the y values by 4. So 1 times 4 is 4. That's going to go out there. And then this translation we're adding on the inside. Inside, it's opposite day, so we're going to be moving left and right since it's with the x's, and since we're moving left and right, we're going to move left too since it's opposite day. So really, these just require you to know all of them. And this one won't be too bad. 2 on the inside really means multiply by 1/2 on the x's, and then negative means reflect over the y-axis. And I think that should be enough to get you guys through this lesson.